Hello, everyone. This is the Geek Narrator podcast. I am your host, Kaivalya Apte, and I'm back with another very interesting episode and a very special guest. So, we have today Kishore Gopalakrishna from StarTree, and who is one of the co authors of Apache Pino and has been contributing to real time analytics and streaming industry from a long time now. So, welcome, Kishore. I'm really excited to have you here. For our viewers, let's start with a little bit of introduction about yourself, about a bit of your background, and what are you currently doing at StarTree?
Yeah, absolutely. Again, first of all, thank you so much for having me on this show. I've watched a lot of shows. I know you recently started, like probably a year or two ago, and I've thoroughly enjoyed all the episodes that you have been doing. And in fact, I'm also learning a lot from the talks that you have. A brief intro about myself, Kishore Gopalakrishna. I'm the co-author of Apache Pino and also the co-creator of other projects like Espresso, which is like a distributed key value store at LinkedIn, and Apache Helix, a cluster management framework, Third Eye, which is an anomaly detection and root cause analysis service as well. And what am I doing now at StarTree? I'm the co-founder and the CEO at StarTree. So this is a project or a company around Apache Pino as a service. So that's what I'm doing right now. Super happy to be on the show and looking forward to it.
Awesome. I already shared this with you before we were chatting, like before the recording, that we've already done like Apache Pino episode. So in this episode, we are not going to go really deep into Apache Pino itself, like the technical things, because I've already had Tim Berglund talking about it, and it's right there. So if our
Yeah.
viewers are interested in that, please, I'll attach that link in the YouTube description so you can go over and check that. But in this episode, we are going to talk about experiences, right? Because as Kishore said, he has been building these systems for a long time now, and some of the really amazing systems like Espresso, of course, Apache Pino, Third Eye, and Helix. And that along with building those systems, of course, there are so many use cases that these systems are solving and have solved in the past. And there are so many experiences. So this episode is going to be focused on the experiences and use cases and everything around solving problems using these amazing technologies. So, to start with, I want to go back in the history and understand from your perspective. So, if I understand correctly, all these technologies were built at LinkedIn, right? Yeah.
Yes,
So,
the ones
what?
that I mentioned. In fact, even before that, I built a few at Yahoo. I
Hmm.
worked on Hadoop, I worked on Zookeeper, and I also worked on a streaming system called Apache S4. For most of them may not know about it, but this was before Samza, before Storm. This was a stream processing framework that we built at Yahoo.
I guess I've only heard about it, never really read anything. Um, but yeah, so I want to understand. Let's go back up to LinkedIn point, right? What was the problem, and why was something like Apache Pino built?
Mhm. Yeah, absolutely. Again, I think as you spoke about the distributed systems, right? At some point back in Yahoo, I was a user of distributed systems. And I think LinkedIn is where I first got an opportunity to build something from scratch. And it was always my passion, and I always wanted to learn. And then I think I was very intrigued by this statement by, if you're familiar with Leslie Lamport, who's they call his like godfather of distributed systems. And he has this amazing definition of distributed systems, which is it's like a computer that you don't even know that exists. It fails somewhere, but it renders your own computer useless, right? And then if it is so much of that is packed into just that one statement, and that always intrigued me, right? In terms of like how is this some random system failing somewhere is actually making my own system useless. And that's really the challenge of a distributed system that most people underestimate, and we think it's just about writing some code and it's like a single node, and it just everything changes when you go from single node to multiple systems. So that was why I got into building distributed systems. And after building Espresso, that was like a distributed key value store at LinkedIn. I got this opportunity to work on this analytical system, right? But at that point, I was like, hey, this analytics has been so old, and there are like so many different systems out there, right? Starting from the Oracle to Teradata to you name it, right? There are so many different systems. Why do we need to build another one? And I was like, I talk about this in other episodes and also some of my as well, is I really didn't want to build another database. And I think the interesting thing was I were these two different worlds, and there was this analytical world and then there was transactional world. And this problem that we were going after was trying to solve both the problems in one system, right? So you look at this transactional world, there's a lot of reads that are happening, right? So million QPS is not a big deal in the transactional world, right? You will have those many reads and writes per second. But whereas on the other hand, in analytical world, no one does that. There's no, but it's not a key value lookup. You have to scan a lot of data. You have this lot of complex queries. So complexity is very high, but the read throughput is not very high on the analytical world. And whereas on the transactional, complexity is low because it's mostly like a key value lookup or you're editing a particular primary key. But this was really bringing both of them together. And the reason why it was bringing both of them together was we were taking analytics to the next level, which is most people, when we say about analytics, they think of, oh, yeah, the business analyst or like the execs within the company looking at some dashboards. And but LinkedIn has this had this amazing idea where they wanted to show analytics to like hundreds of millions of LinkedIn users. So that was an amazing. Just when I heard about that, was really exciting for me. And also, we had another system that we were using as the backend. This was Who Viewed My Profile is the first application, and we had built that already using something like Elasticsearch. And the interesting thing was, no one expected that so many people would actually use this product, which is Who Viewed My Profile. And once we saw like thousands of people querying it at any given second, that's when we saw like the backend started falling apart. We It was a nightmare in terms of managing this 1,000 node cluster. We had to keep breaking the cluster into hundreds and hundred nodes each because they couldn't really work together. It was very expensive. But the best part was the value was very high. So even at having 1,000 node cluster for something like Who Will My Profile was worth it for LinkedIn. And that's where it was like a big game changing moment for LinkedIn, which is wow, this is amazing what we can actually achieve when we build products like this and serve it to our end users. And that's where we said, hey, if we can make this more efficient instead of needing 1,000 nodes to run this, if it is a lot lesser, then we are onto something. And I think that's what led to the creation of Apache Pino, which is let's change the cost of per query, if you will. I think that if you look at from a very big picture, the cost per query in existing systems was very high. And we said if we can reduce that cost per query, then we can pretty much start building products for every vertical that we have in on LinkedIn. And that's what we built. And then we ended up having almost like close to 70 to 80 products right now on LinkedIn, all being served by Apache Pino.
Amazing. Before I ask you about the cost per query thing that you mentioned, it's very interesting. I want to understand from the project perspective and someone who is working on this project. Oh, there is this problem. Who viewed my profile? I want to build something. Of course, there is value, but it takes the execution, which is the most difficult part, like to get that value. So, how do you convince that I want to build a new system and something probably which is never built like that? To and how do you make the rollout process and getting the success metrics and making sure that you're doing the right thing and moving in the right direction? So how was that process like?
Um, that's a very interesting question because most people look at the end product and say this is how you build something, but there is a lot of kind of art that goes behind the scenes in terms of getting to some going from an idea to actually having a finished, fully finished system. And it typically starts off with like just your vision in terms of how far do you want to take this, right? I think you want to make sure that whatever you're building is like, especially if you're investing in something like building a new database, because first of all it takes 2 years minimum to build something like that, and you need to make sure that the management understands that. And you, because most of them say, hey, I can go and build a database in 3 months, 6 months, and none of them happens in reality. It takes 2 years to build it and probably another 5 to 10 years to actually perfect it and mature it. And I mean, even if you look at something like Kafka, it was started in 2009 at LinkedIn, right? So it takes a long time for these systems to actually mature and solidify. So just setting that expectation, both with within your company in terms of how long it's going to take to build, at the same time making sure that it stands the test of time, because you don't want to just solve the problem that you are seeing right now, because if you solve that, then 2 years from now you are seeing a new problem. That means you are going to keep building another system every 2 years. So it's making sure that you are seeing very far in terms of what problem you are trying to solve, but at the same time making sure that you get to solve the existing problem in time, and because you don't want to take 5 years to say to build solve the problem that you have today. So it's that designing for 10 years, planning for the next 2 3 years, and then just making sure that your implementation is catering to the current needs, but at the same time it is flexible to take it all the way, right? I think that's an art, and again, a lot of these come with experience in terms of building systems. I learned a lot from Hadoop, Zookeeper, Apache S4. So when we build all these systems, every time you build a system, you make some mistakes and you figure out like, hey, this is something that I didn't really think about, right? And the challenge for all these things is the unknowns, right? You can always, if you know something, it's a lot easier to design and and plan for it, but you always have something that is unknown. You don't know what are all the things that are changing around you, and you got to be ready for that, right? And
Yeah.
that's the it's especially the parameters that are not in your control. You might start building something, suddenly you're, let's say you're planning to build during an disk era, and suddenly SSD comes along, and now you're like, oh my god, I optimized everything to work on disk, and suddenly SSD is there. It doesn't even care about random access. I can get a really good throughput. Now
Mm.
your entire architecture is not really built for that, and that's why you have these systems come in every 10 years, every 15 years, and suddenly network might change, might become very very fast from what it was before. And now we are seeing even the object store is actually capable of much larger throughput than what it was. So you will see new variations in systems there as well.
Yeah.
So it's like what you can control, what, and then there are things that you cannot control that's beyond the scope of your project. But then just keeping all these probably 10,000 variables in your head in terms of trying to design that system. And also the other bigger challenge is not to solve the entire world's problem, right? Just to be very focused in what you're going after, because it was very tempting for us to solve data warehouse problem as well, because
Mm.
analytics is such a big thing, but we had to stay focused in like the problem that we were actually solving.
Those are great insights, and I believe those insights are not only limited to building a distributed systems, but like any project that you're working on, and you need to keep your focus really tight, and you need to also take, have some vision in terms of how the technology will change and how your architecture would adapt to it and all of that. So those are great points. I want to understand, so these days, testing systems, there's a lot of technologies. There is, definitely cloud services there's a rise in deterministic simulation testing as well. Back in the day, what kind of testing was popular, like for complicated systems like Apache Pino or Zookeeper or Helix? And so I believe, like, whenever I work on some systems, there are of course some known unknowns, and then there are unknown unknowns which you
Yeah,
don't really know. So how do you come up with techniques to roll out these systems while testing them and making sure that you're also fixing bugs? So what kind of testing was done?
that's a great question, because I think this is not about Apache, but I'm going to go back to Espresso. This is one of the things that I'm actually, I stumbled upon it on by accident, but I found that was the best testing methodology that we actually figured out. And the challenge was like, whenever, especially with a distributed system and it's a strong, consistent system, when things go down, you end up in an inconsistent state, and then it's just a very hard problem to solve. And I also saw this in the way Zookeeper was built. And I think if you're familiar with the Jepson testing that Kyle came up with, which tests all these distributed systems, Zookeeper was probably the first one that actually passed that. And I think that was one of the systems that had a very thorough formal testing. So the first thing is to make sure that, as you mentioned, there are known things and there are unknown things. So the known things, you want to make sure that your design is like really solid. You can think about what happens if something happens in the sequence. But as you mentioned, there is all the unknown is a lot, and especially it's a long tail. It might happen like once in a month, but it will happen, and that's going to be really bad.
Yeah.
So when we launched Espresso, we had the same problem. We had done all our testing. We could think about all the different scenarios, but then we launched. Very soon, something would fail, and then we would break our head in terms of what's exactly happening. So what we ended up doing is, this is again very similar to the chaos testing, right? Which is you're randomly killing nodes and things like that. But that just conceptually that is good, but then there is a lot of craftsmanship that needs to go behind the scene, which is how do you simulate these things, and what do you capture when things like that happen, so that you can actually, when it fails, you have enough data points to figure out why it failed, and then you have enough data points to actually simulate that in terms of building a new test case that actually can reproduce that exactly. And you also want to stop the system when that fails, because if you continue to keep doing something, that system would have gone into it. So there's a lot of these other things that you need to keep in mind. So what we ended up writing was like just one test case for the entire distributed system, and we said, okay, we're just going to keep trying all these different combinations, but after every combination we verify, is that the right state that it should be in. We verify all the we used to call that as the variants, like all these invariants, are they actually satisfied. And we actually built this amazing system, and it was literally like one file. That entire test case was just one file. We didn't have to, like, all the other test cases that we had written was like some probably 10,000, 20,000 lines, but they're all like completely useless, because this one test case, we couldn't get it passed for a month. So every day we would run this test case in the night. In the morning we come, it has failed. So the whole day we would fix that bug, we would redeploy it. Again, it would run, it would the next day. It's like we went over this for pretty much the entire month. And it's amazing the number of things that it actually catches. So for me, it is always about not just limiting ourselves in terms of what test cases that we can actually think of, but
Mm.
can we actually have a test case that keeps coming up with new test cases that you don't have to think. So we applied the same principle with for Pino as well. So we have a test case in Pino that keeps generating new queries every time it runs. So it's not the same query. So it's like you
Okay.
just give a template and like a bunch of variables and all the entire space on all the different dimensions, and it would just try out every possible combination every time it runs. So same thing, we would run those test cases, compare it against Postgres or a SQLite, make sure that returns the same thing. So I think, to me, for distributed systems, you got to go beyond the known test, because there is just so many number of use cases or test cases that it's impossible for a human to actually think about all those things. And in fact, we actually wrote a paper on that. I think it's called Data in Veritas, and we modeled it as there is a state machine behind it. It's quite complex to actually come up with it, but the return on that investment is huge, because you get to write that test case once, and then it like the rest of your life you are actually getting benefit, because it's coming up with new and newer test cases every time. So I think, to me, that is something that I learned, and I was very happy when I found that you can actually invest in one test case that actually keeps generating lots of test cases dynamically. So sorry, that was a long answer, but I it was
No, I
interesting
think
that you actually asked that.
no, absolutely. Those are great insights, and I'm not even sure if you've talked about it anywhere else. So I'm really happy.
Yeah, no, I haven't. I think that's why I was like, wow, he's asking me this question. So I think it's a good one to chat.
No, I think that's an amazing insight. Coming back to the cost per query, cost per query thing that you mentioned,
Mhm,
and I was recently listening to your keynote at the StarTree summit,
mhm,
and you mentioned a very interesting thing that the at LinkedIn, like logging an event was very expensive,
mhm,
and how Kafka made or optimized the cost of logging an event. So I
mhm,
want to understand, right from there, and then slowly coming to the cost per query thing that you mentioned, like
mhm.
how did Kafka play this role in cost optimization, and what exactly changed that logging an event was not as costly as before?
Yeah, that's a very interesting thing. I want to sort of step back and then look at like This is a common pattern that happens in pretty much every time you want to make a drastic change in terms of the problem that you are trying to solve. You have to think completely different, right? And I think in the previous keynote I had given this example of like just walking to having horses to actually having bicycles to motorcycles to cars to flights and to rockets. And if you look at it, what is they're all solving the same problem at the end of the day, which is distance. But when your distance that you want to travel changes by an order of magnitude, you cannot just take the same solution that worked for a smaller distance, like you're walking to a next block. You cannot say, I'm going to
Mm.
walk from this place to another place. So you got to completely redesign, rethink the problem. And as part of that, you're giving up something for something else, right? If you're thinking about from a car to a flight, you're not thinking about flight as there is one flight per person. Now you are thinking about, oh, I can actually take thousands
Mm.
of people at the same time. So that means you're amortizing the cost across all of them. So I think that's really what happened with Kafka as well, which is it was giving up something. So Kafka first gave up transactionality on like earlier systems, ActiveMQ and RabbitMQ. They had a very strong transactionality, which is like you write a message, you can actually say a transaction dot start and push a message and end, and then you had Java messaging, JMS spec, and you had to adhere to that spec. So there were a lot of these kind of restrictions that was built in the messaging layers. And Kafka said, okay, now I'm now thinking about logging hundreds and thousands of events. I want to pretty much know everything that a user does on LinkedIn. So we cannot live by those rules. We cannot restrict that. So then what Kafka ended up doing there was very simple things like batching, right? I mean, it had to, it would, when you send a message, it's not really sending a message from a producer point of view. It's actually batching all of them. So what that does is end up sending, you get a lot more compression. So you're getting a better use of your network. If you're sending one message at a time, one, you are incurring additional latency because you have to wait for the act from the other side. So you cannot send, but now you can send a lot of messages at the same time, but you get compression, so the bandwidth is used better. At the same time, you're getting a lot of very high throughput, right?
Mm.
So what basically Kafka did there was it first gave up on the latency for throughput, right? Again, that's a trade-off that it made, because now what it makes a lot of sense, because you're not sending like 10 messages, you're sending tens of thousands of messages. So it's okay for you to actually give up on that. So that's the trade-off that you need to first do. And then on the other side, there was now the disk were changing. So you didn't have to rely on the disk, and now you had RAID, and you had all these different ways you can actually parallelize your writes across all these different disks, and how you actually write it. So that's another mechanism that Kafka used. And last but not the least, there was this additional thing of all these other systems would actually take the payload, they would deserialize it, they would actually look into the headers and all those things, and then they would do a bunch of things before they actually write to another. So that means it was getting into the user space of the program, right? That added additional CPU load, additional memory load. But Kafka came up with the zero, not zero MQ, what is that?
Zero copy.
Zero copy, right? So you don't have to really bring any of these messages. Again, it was it like Kafka that came up with? No, absolutely not. Zero MQ existed even before that. The Apache S4 that we built, actually we used that when we were exchanging messages between different systems. But there are all these different innovations that happened in different parts of the system, and then Kafka used all of those together and then brought it into one system. And that's where you now started getting a much better throughput. And also the concept of offset and everything else was also something that was common in change data capture, right? If you look at Oracle, that's how they had this concept of LSN. And I think that's another way they change the consumers, right? Instead of the consumers, if you look at zero MQ, sorry, active MQ and others, they are maintaining the state, and they simplify the job of a consumer, because you can just start a consumers, it's more of a queue. So they try to provide exactly once, right?
Yeah.
And what did Kafka do? It compromised on that as well. So you don't have an exactly once processing with Kafka. You have an at least once, right? And
Mm.
then how to reason about how do you build work. Again, this it added a lot of complexity. It's like something that was as simple as just send a message and consume a message, and I don't have to worry about all these things. But then it added a lot of complexity, but it also gave a lot of additional benefits in terms of the throughput, that you could actually send thousands and millions of messages.
Mm.
And but now when you look at the grand scheme of things, because it's not doing transactions, it's not giving you the exactly ones it could, that's where a lot of complexity came, and also a lot of CPU would be used for that. And now all of that is gone. So now you oh at the grand scheme of things, you will see the cost per log go down drastically, right? I think that's so all these things actually added up. I'm sure I'm missing a few more there, but it's really is not generally just oh there is this one amazing thing that actually changed the whole game.
Mm.
Most of the time it's not. It's really finding out what are the most important things that matter, and like understanding first of all like why is something expensive. I think I really like that thing about Elon Musk on how he talks about the electric vehicle and the rockets and other things, on how we went why are electric vehicles costly because of the lithium battery, and how what we can actually do to reduce the cost of that. I think just approaching from the first principles and
Mm.
understanding what is making it expensive, and then also asking the question, is it really that valuable, right? And what if we let it go? Is like in case of Kafka, the transactionality was not there. They compromised on that, and also on the exactly once.
Mm.
But it was still useful because it was not for your financial data.
Yeah.
It was just logging events. It's okay if you occasionally said like someone viewed this multiple times. It's not the end of the world, right? So I think it's a combination of use cases, making the right trade-off. I think that's what led to the drastic difference in terms of cost per log.
Mm. I think those are great insights. And again, it's all about trade offs like anything else
Yeah,
in software engineering, right? If you understand the core problem, I think it's easier to keep your focus narrow and take one step to solve that problem while trading off something else, which is not very important for that specific use case. And then
yeah,
taking these steps in forward. And I think you also mentioned about the first principles. I think that is really important while working with distributed systems, because at the really core of it, it's all about these first principles, and if those are broken, then probably it won't work at the higher level of scheme, right?
exactly. I think that's a great point that you brought, because you cannot cut corners in distributed
Mm.
systems. You can do a calculated trade-off and say this is what I'm giving up. But if you try to cut corners and say we will deal with it when we actually get to the scale, that's when most of the systems actually don't survive the test of time. They will be
Mm.
really good in a single node on this very small data set, but the moment you scale to a certain level, then they start breaking down. I think that's
Okay.
those are all the signs of a compromise design very early on.
Good point. When you started explaining how you built Apache and a little bit about the history, you mentioned, let's say, at a broad level, two types of systems like transactional and analytical use cases. I was talking to like multiple folks around these systems, and so transactional is typically concerned about one record, like one transaction, and analytical is like really querying like probably millions of records in the system,
Right.
and then filtering and doing some aggregation and all of those things. So I want to understand the cost per query. So how does that differ in transactional systems versus the analytical systems? And then probably we can talk about how Apache Pino solves that problem of higher cost per query.
Yeah, no, absolutely. In the transactional, as you rightly pointed out, most of the time there are two main operations that you're doing. Either you're doing a write and updating some record, or you're reading a record, right? I think the
Mm.
most of the time. And there are also multi-gets, multi-ports, and all those things, but yeah, all of them at the end of the day translate to these two primitives, right?
Yep.
From a user point of view, you can add higher level primitives, but from a system point of view, most of them get translated to this. So there, since it is a key, and then most of the time you are updating the whole record, right? You're not updating one particular column. So what it ends up, the main task that your system is doing is like finding where that record is,
Mm.
and that's where the key based index works, which is like most of them end up using the B tree. It's a very well known thing. And then there are also LSMs which try to, that's another strategy that most of the systems end up using, which is they don't want to do an in place update, right? I think that has its own challenges in terms of defragmentation and defrag and things like that. So
Yeah.
LSM comes in and says every append, every write is the new append, and I will do the compaction behind the scenes. But those are the two different strategies that most systems apply in the transactional model. But when you get to the analytical, that's it. The right part is mostly append. But however, as added, we are seeing a lot of use cases in analytical world as well, where the data can change post fact, right? So that's why we have the upsert, and is like the only system that has like a row level upserts as well. But the read is the one that is a lot more complex on the analytical side. So there are two things that happens in the analytical world which is different, which is your query typically has to read a lot of rows, and it also but at the same time it doesn't need to read all the columns, so it needs to read only few columns.
Mm.
So that's where you have this columnar storage where you can just pull the data that you're reading. You don't have to pull a lot of other columns. So your cost in terms of the disk IO as well as in terms of what you pull into the processing layer is going to be minimized. So I think those are the things. You get much better compression as well because the data size becomes smaller with columnar storage. That means you are also using less IO for your disk or network, however you are planning to read it. And but you do pay a cost in terms of deserializing and serializing the data. So that's typically the cost in terms of just reading the data. But then there are other things that you also do. It's in case of operational, once you read the data, you're most likely just returning the data back to the client. So I read this record, I got the value, I give it back to the client. But in analytical world, it's not just about accessing these, it's about applying additional things on top of it. And that is, you might have to filter it. Say, okay, yes, I read these records, but I want to match only the records that have this certain criteria, either they're from this country or whatever field that you want to apply that filter logic. Then you might want to do a aggregation on top of it. You might want to do other kinds of transformations on top of it, and then further do aggregation, projection, group by, and few other like having windowing, joins. So there is like the complexity gets added even after reading that. So I think overall the total work done in an analytical system has a lot more parts than just the
Mm.
what is it, on the transactional part.
Interesting. I think those are great points again. And those are like the key differences among these two systems. And again, it boils down to you trade off the right things while achieving some other things. And like you mentioned, like in analytical world, you don't need all the columns. How you can use
Yes.
column oriented storage to optimize on that. And that comes up with additional benefits like compression and also quickly getting all the interesting columns that you need for the query and not
Yeah.
like the entire row. So again, it boils down to the same principle. It's very interesting. You talked about upsurds, and I want to tell you a little context, like how I
Hmm.
got to know about and how I got interested into that. I'm not sure if you remember, but in one of my previous companies, I was tasked to, there was some real time analytics use case, and I was
I see.
tasked to, we have this architecture. Go
Hmm.
ahead and compare different solutions, mainly open source, not like
Hmm.
paid ones,
Hmm.
and figure out which one works for our use case. So
Hmm.
I compared Apache Pino, ClickHouse, and Druid, and different systems. Uh, Upsert was one of the many features that I
Hmm.
really liked, and that was like one of the key differentiator
I
why
see.
we chose Pino, right?
Okay.
Because none of the systems were actually supporting upserts as a first class citizen.
Hmm.
There were like different hacks, workarounds, but that they were not working. And that's
Correct.
when I first probably chatted with you as well and interacted with the community. And then the community was another very like interesting part for us, because if you have the support from community, right, it makes a world of difference, because
Hmm.
you will get problems, you will
Yep.
figure out some issues that you cannot solve because you don't have that level of
Hmm.
understanding. So that's a little bit of context, like how
Okay.
upserts is very close
Yeah.
to my heart and how I got in touch with Pino and the community. So I wanted to talk about the community a little bit here, right?
Hmm.
Because for making any project, especially open source, this successful, you need community effort and contributions. How do you lead a project with a vision that, okay, it is going to be open source, and how do you lead such a community of enthusiastic people? And what are your, like, some of your learnings there, like technical or non-technical?
Yeah, I think I've been involved with open source right from Yahoo, right, and from the Hadoop days and in Zookeeper, and I've been very fascinated with how open source works, and I think that's one of the reasons why I actually joined LinkedIn as well, which is because they were very supportive. I saw projects like Voldemort, and I'm not sure if Kafka was out at that time, but it was really interesting to see the companies. So I think for me, that's one of the biggest advantage of open source, even from a company point of view or even from an individual point of view, is this becomes your resume, right? I worked on XYZ project, and all your work is open. You Someone can actually see what you have done. So I think that's the first benefit of open source. And I think for me, there were lots of different dimensions than how I think about the community. One is definitely, for me personally, I'm still in, yes, there is a lot that we give to the users and they can actually use, and something like we were helping you in whatever you are doing at the company. But at the same time, there is a lot of things that you get in return, right? I think for me, the biggest thing was the ideas. They actually push the projects a lot, because at some point, without an open source, that project just gets tied with the company where it originated and to the requirements, right? So I mean, not
Hmm.
just necessarily about tying to the company, but it's like what problem it's actually solving. So for me, wouldn't have come to this stage if it was just still solving only LinkedIn's problem, right? I think same thing with Kafka, though there are still a lot of changes that happen to Kafka even today. Uh, that's because of the wide adoption and then the wide number of variety of use cases that end up adopting. So I think for me, that's the first and foremost, is like it's a win. It's
Hmm.
the users win and the creators also win. I think that's a very important thing. But the way I think about open source and community is the most important thing as for that to happen. And that's where I feel that you're getting like a first hand experience, what works, what doesn't work. And also, here is how I'm thinking about using the project. And and I think for me, a couple of lessons that I learned was definitely making sure that the community can actually work together. I've seen a lot of communities where there is, even though no one is everyone is volunteering, but there is a lot of factions that get created, a lot of groups that created. There is always this like, oh, their idea versus your idea. So I think it's still a lot of work that most people don't realize, that it is important for you to make sure that you hear everything in terms of what are the, and then also build the process around the community. Say, this is how we operate, this is how we, yes, everyone can have different opinions, but this is how we actually resolve them. And at the same time, making sure that the community is respectful with to each other. I think that's another thing that I have seen in, I don't want to name projects, but I've seen a lot of projects, really good technology, but they're not successful because the community was never able to come to a proper process or even have clear resolution, and there was always this animosity built within the community. So those things I have seen, like the worst part of those things, and I've always been very paranoid about that, and I always make sure that everyone in the community is heard, and we always make sure that even when we answer the questions in Slack, we always make sure that we are helping people. Doesn't matter how simple or how, sometimes like most people, like the documentation is there but they don't read it, they just keep asking, and then we make sure that no one goes and says, what, didn't you read the documentation? Because that's like the, like, why are you not reading the documentation? But it's understandable that sometimes it's hard to find, it's not clear, so we always take time to actually address their questions and help them. And in the long run, it definitely pays off, right? And there are a lot of people who end up becoming contributors, end up becoming committers. But I'm not, but this is a very small percentage of people who end up becoming contributors and committers. But
Hmm.
irrespective of that, there is a lot that you can learn from the community. So overall, I think without community, open source is like, it's not. You're right in a way that most people think of open source as, I just put my project in GitHub. That's not going to go anywhere if we don't have the
Hmm.
community. I think it's, and that's one thing that I think Apache did really, really well. Apache Software Foundation, and I think they established this motto of community over code. So I think that's, and it also gives that, okay, even if the creators move on, there is the community that actually takes the project to the next phase.
Interesting. Absolutely. And I can totally resonate with it because I got the same support and I got the same feeling that, okay, this is a great community, and if we adopt this technology, and we will get support if we get stuck at something.
Absolutely.
And one of the other important point, because these open source projects, like for example, Apache Pino has StarTree, right? Like there are some other open source companies, like for example, Kafka has Confluent.
Mhm. Right.
So whenever I talk to the community, it never felt someone is trying to sell me something, right?
Mhm.
So that is another point which is
Yes.
really important when someone is just trying to get the understanding of what this technology means. And as soon as I get this vibe that people are trying to sell something, probably it's not great. And I don't
Yeah.
want to name things, but I've also seen some communities where as soon as we ask some questions, and there are like, oh, we don't, like open source version does not have it. This one has. So do you want to try it out and something like
Mhm.
that? So the feeling itself goes away, that it's not
Yeah.
like you're trying to help them. It's, oh, this is available, let's buy, and something like that. It's okay, at the end everyone is selling something,
Yeah.
but in the community I think that separation is also very important, at least in my experience. But those are great points, and thanks for sharing the experience. I So let's assume, and this is a very interesting question, let's assume that you are at LinkedIn, right?
Mhm.
Or some similar size company
Mhm.
in 2024, right?
Mhm.
Same problem comes up. Let's say there is no Apache Pino, nothing like that. But if you have to build Apache Pino from scratch in 2024,
Mhm.
how would you do it? What difference it would be? And it can be anything, like technology choice, or how you would release it, or how would you think about it. And I guess what I'm trying to ask is, in a way, that what challenges did you face that you would want to avoid now because you already know those.
I think that's a good. I always keep thinking about some of those things, and it's not like we did every decision was right in terms of. I think the major one that comes to my mind is directly building the system on top of blob storage from day one. Right? I think
Mm.
this is the world is going. I don't think it's still there. We have tried a lot. We have done a lot of things. I don't think S3 or any of this blob storage is there to give the same level of latency. But I think that's going to be the future in terms of these systems going to the next phase where they can actually provide that low level latency. I think that's one major thing that I would change. I think the language part is, I think my two things that I look for, all of them talk about like Rust, CC plus, and all these. I worked a lot in CC plus, but nothing beats the real design and the real code and the real implementation. You can take a C plus plus and make and have the worst possible implementation. You can take Java and have the best possible implementation that beats a C plus plus. And you see, I would say pick one that you are comfortable with, your team is comfortable with, but at the same time make sure that you can hire people who are comfortable with it. I think that last part is something that most people forget, and that was the biggest challenge that I had when we were at Yahoo with CC++. There are very few really good CC++ programmers, and especially when it gets to this core distributed systems and also the ecosystem, right? How many libraries do you have that are
Mm.
actually very well tested at scale that you can actually pull off the shelf and then start working? Because I still remember, like in CC++, we couldn't even find a good hash map. Like every C++ project probably built their own hash map. I was like, why? So I think you don't want to keep reinventing those things. So you want to also think about a good ecosystem that you can actually work, because time matters at the end of the day, because distributed systems is probably, so if you look at the end of the day, 60% of the code in a distributed system is probably just pure cluster management. It has got nothing to do with the system that you're
Mm.
actually building. And most people underestimate those things, right? I mean, they think, okay, I came up with this really cool data structure, I came up with this really cool way of accessing things on disk, but those are all like then becomes like 10% of your code or 5% of the code. There's like all these other things that you need to build to actually make it work at scale is what takes up majority of the time. So I think for me, The only big change that I would do is like just start off with blob store, and I think that's one thing. And I think there is another one which is probably not Zookeeper is one thing that we had actually used. And again, we are managing thousands of nodes with it, but I think when we get to like hundreds of thousands, I think that's where I would probably. But frankly, there is no other system that is as good, as stable as Zookeeper. I know the world has a different view in terms of. I think to me that view came because of the way Kafka used Zookeeper rather than problem with Zookeeper itself.
Yeah,
But that's another one that I would probably think about not using a different system but designing it differently.
very interesting. And those are really powerful set of like guidelines, right? And like I've seen often people, of course, Rust is this new cool thing and everyone wants to learn it, and everyone should learn it probably,
Yeah,
like just to
absolutely.
understand. But that doesn't mean that you get blocked until you learn Rust. If you know Java pretty well, and if you know that you have great support, if you want
Yeah.
to solve a problem, just go ahead, right? And that's not, that rarely becomes a problem. And as you mentioned, it's also possible to write really bad code in Rust, really
Yes.
like memory unsafe code probably as well.
Yes.
And on the same lines, you can really shine if you use very mature technology like Java. So
Yeah,
those are
I think
really,
these languages, building a community around that and building that ecosystem is not easy. If you go back a few years ago, Go was like that. Like it was the cool language that everyone
yeah.
wanted to work on. Yes, there are a bunch of things that got built. It's still a great language. I like a lot of things. But that after some time, the same set of problems started coming even with Go. What about this garbage collection and what about this fragmentation and all those things? So I think it's
Yeah.
still all of these look really cool because they give up a lot of things that the other systems ended up solving over a period of time because they can start small and but as the target market keeps increasing, now they need to add all these small things that everyone is asking for, which you probably didn't even
Mm,
think about in the beginning, and that's when it becomes really. I always think about how Firefox and Chrome, like Chrome was super fast when it came because it didn't have probably 90% of the functionality that Firefox had. And then they kept adding everything, and Chrome is so slow right now. And then you get to another browser which is like light and then doesn't have all the baggage that it needs. But that's the thing. You people underestimate the baggage that gets added and the tech debt that gets added as you keep implementing all these new features
mm,
that you need to make it fully complete, functionally complete. And
absolutely.
that's a long journey, and people underestimate that.
Yeah. Lack of features is also a feature, and
Yes,
because that brings simplicity. Amazing. I want to talk a little, since you mentioned blob storage, and I've been talking to multiple folks building these systems. They want to separate compute and storage and then have everything stored in blob storage. So you get cheaper
right,
storage and cost optimization. But there is, of course, latency trade off, as you talked about.
right.
If I remember correctly, and if I understand correctly, Pino's architecture. So there is always this like deep store, like different segment store, and
Hmm.
compute is already separated. And
Hmm.
then there was this tiered storage, which was probably recently introduced. So what was that transition like? And how far is it from, let's say, something like totally, like completely using blob storage? What are the challenges that you see?
Yeah, actually, that was one thing that I was very impressed with folks who worked on Pino because this is a fundamental change in terms of going from a local storage to just using blob storage. But the abstractions in Pino were so good. Again, I don't think anyone thought about like yes, that there will be someday where we'll be just working directly on S3. But surprisingly enough, the abstraction was so good that we could actually make everything work on S3. Yes, there were few things that was not the best because you could actually get what happens with when you go from local to S3 is your parallelism changes. Like you can actually have a lot more threads going at S3, and but then while the data is coming in, there is nothing to work. So we had this parallelism per segment, right? So that was one of the big difference that we had. But what happens with that is like when we ask for the data from S3, there is 100 to 200 milliseconds delay, but that thread is just sitting and idle and waiting. But that's not a problem with local because it just comes back within few nanoseconds or few microseconds. So that's not a problem, but that becomes a problem because this thread is just waiting. So we had to do a bunch of things in terms of pipelining and bringing in the concept of multi-threading within the segment. Uh, but as I mentioned, the whole abstraction was so clear that with very minimal surgery, we could actually get the whole S3 thing working. And I think the way we created different indexes having different buffers, like we had the right separation in terms of the forward index, inverted index, range index, StarTree index, all of them were like really different buffers. So we could actually read all of them in parallel. And we could also do things like prefetching, which is before we need something, we as soon as the query comes, we can say, hey, we might need all these things. So you fire off another thread behind async that actually goes and makes the data ready for, so that when the segment starts processing, it's like the data is already available. So I think there are a lot of cool things that we ended up doing. Was it the best? No, but it was still cool to see like a system that is almost 5 to 6 years old was is able to actually make this change and make S3 as a first class citizen. So the best part is we are now able to see 200 to 300 millisecond latency even on S3, right? I think that's a huge improvement for us, and being able to do sub-second on S3. I think that's, we are very happy. And then that, now even in fact we just launched our cloud free tier on StarTree Cloud. That entire thing will be running on S3 on tiered storage. So you get this ability to get the best performance, but at the same time at lower cost, because S3 is not that expensive compared to SSD.
Awesome. That makes a lot of sense. And some of the interesting points that you mentioned. For our viewers, I've done this episode on tiered storage with Neha. And if you are interested in really deep details about tiered storage, and so
Yes.
I'll link that episode, please watch that. But yeah, tiered storage is very interesting. Like I guess Kafka also has it now, but I might be
Yes.
wrong. Um, cool. I want to talk a little bit about like the customers that come to understand, oh, what is real time analytics? Do we even need
Mhm.
it? And some of the use cases. Let's say I'm a customer, or let's say a user. I have a ton of data and I'm really dicey. Do I really need something like Apache Pino? Do I really need real time, or I'm fine with, let's say, batching or even micro batching technologies? Because let's say I already have those tech stack. So what are your recommendations typically to understand that, do I have this problem that I need a solution like Apache Pino?
Yeah, I think that's a great question, and I think this is something that I was opposed to as well when we were building. In fact, they're already built, and it was very expensive, the Who Would My Profile. But I was like, why do we need this?
Hmm.
It can Why do we need any of this in real time? Can we just tell them who viewed their profile like one day later or like a week later? What are we going to lose? I think the interesting thing was like LinkedIn had a very strong experimentation framework. So we could clearly see the difference in engagement if we were doing it one day later versus immediately. So that was a no-brainer for us. But a lot of people don't have that mechanism, right? So I'm going to try to answer. So if you can make it data driven, that's the best, because then it's like you're not doing anything hypothetical, or you're not based on, oh, this person said it's going to be useful, so I'm going to actually do it. So if your company has the experimentation culture and the right frameworks, I would always start with that, because that cannot never lie, right? So you will know what are the things. And the second part, I think, is really, I would try to change the way they approach this, right? And as you mentioned, like most people think about, do I need it? But I think what you really need to do is put your users first, and then see, do the users do need it?
Hmm.
How can we actually improve their life by providing something like this? And when you have that pivot in the way you think, a lot of things changes, right? And I'll tell you a very as simple as a report generation. And if you look at the report generation, most of them still even today get like an end of the day or end of the month, they get a report, right? And but people think that's good enough, but it's actually really bad, because most of them are like looking at the report and they're like, okay, this is not really useful, because I already know about some of the things that you are saying, because you are sending me at the end of the month. And two, oh, this looks interesting, but what do I make out of it? Because I need to ask another question, but now I need to wait for another month or another day to get that report. Or Even that will not answer because I need this additional view of the data. And where do I go? I need to now send you an email. It's like very, it's not self-serve, right? It's so all these report generation tools should basically be a real-time analytics app, right? And that's, if you look at LinkedIn in talent insights, was basically the previous version of that. Was every company would at the end of the month get a report of so many people moved from their company to another company. So let's say Google is looking at this and saying, oh, we lost so many people to Facebook, and this is in HR, or this is in like tech, or this is in this geo, in this skill set. So that's a cool thing, and they would get this report end of the month. But then they would like, okay, is there any other insight, any other question that I want to ask on top of it? They wouldn't get it. Now they had to reach out to the LinkedIn person. They would write another Hadoop job, generate another report. It's like the whole process is actually really bad, right? And so they turned that into a product. And now someone in Google, because this data is already available, every time a
Mm.
person changes the job in LinkedIn, the data comes in, it comes into Pino, and now you just go there, you have the access to the whole thing, and now you can ask all these questions, and there is no intermediate person in between. So it starts off with the product person, right? It's like, what can I build that actually changes the life of my customer,
Mm.
what, and make them really more productive in terms of their day-to-day life, right? And once you start with that in your mind, a lot of things open up, right? Even as simple as, if you try to, these are some of the things that I learned as well, like support calls. Lot of support calls could actually wouldn't be a call to begin with if they had access to the data, their own data, right? Like you call up your bank, "Hey, I had made this transaction, but I can't see it. Did it really go through? Like, I this guy paid, or let's say you're a merchant and I like, so some people paid, but I don't see this in my report yet. Is it done or not?" Most of the support calls are basically this. But imagine if if that other person had the self-serve report or a self-serve app, they wouldn't be asking all these things. There's like, oh
Mm.
yeah, I see this transaction here. Here is how I'm doing. I think there is a lot that can change with access to this data. And two, I think people are becoming a lot more data savvy, right? I think they are very well informed. They can make decision. So you don't need an intermediate person to actually make a decision for you. We are all doing this on a day-to-day basis. We
Mm.
just don't realize. When you're going to airport, or you're going to some place, you're like, how long does it take to actually go there? That's actually a real-time analytics thing. I also bring up the Uber Eats thing as like, how long is it going to take to serve that order? That's also another. So there are a lot of these interesting things that's actually happening. But that, let's say in the call that we had today, after the call, like, how long did I talk? Obviously, probably lot 90% of the time. But you can get like very quick insights in terms of, or let's say right now while we are speaking, we get like real-time insights in terms of like, how are we talking, what are we talking about, or if you have live viewership, what are the comments. It's like there is a lot that will immediately change once we have access to that data, right? I think that's the way I would always urge the customers to think about. And I think, again, there is a slight different mindset in terms of, are you like a innovator versus are you a follower, right? So that's
Mm.
another. Do you want to innovate? Do you want to leapfrog ahead, in terms of your competitors, or you're just going to follow, right? If you look at what Uber Eats did, and then like a restaurant owner is getting real-time analytics, right? Like, just think, if even if you just think about it, that's a huge change from where we were like 10, 15 years ago. And now it's becoming a de facto thing. Like, now there are a lot of other followers. Every delivery company is now forced to do that. So I think that's another way to think about, is what can I do better and be ahead in terms of the competition. And especially this real-time analytics impacts your users a lot. I think if you think about it from that perspective, there are tons and tons of use cases that come up, and then people will be doing it, and then they will continue to build more and more data products. It's just, you just don't realize, because it's so well embedded within the app that you're using, that most people don't know that they're actually using real-time analytics in one way or the
Mm.
other on a day-to-day basis.
Yeah, that has become a norm, like at least for many of these apps. That if you don't see it in real time, you feel like it's down. It's the app is
Yes,
down. you
exactly.
you
You
don't.
want to see the number changing immediately.
Yeah. I mean, you don't say, oh, maybe this real time analytics, this feature is down. You just say app is down. Like it's
App is
that
done.
kind
Yeah.
of impact, right? Thanks a lot for sharing these insights and your experience. I can go on and ask all the questions that I have, but in the interest of time, I think it's best if we leave our viewers here with all the insights from your experience, from the problems you have solved. For our viewers, I'll definitely share all the references that Kishore mentioned in the YouTube description. So please do take a look. And yeah, see you in the next one.
Awesome. Thank you so much, Kaivalya. It was really great to be on this show.